So what are you going to show us today?
What I'd like to show today is a water purifier that is solar powered, and that means that it requires no electricity, it requires no fuel, there is no maintenance, there are no filters, there are no consumables at all in this device. It just simply spits out purified water. Central to the design is what is called a Fresnel lens, which is a light, flexible plastic lens that replaces the heavy unitary glass lenses that most people are familiar with.
So what is a Fresnel lens, and how is it different from other lenses?
Well, let me explain that.
So Fresnel lenses result from the segmentation of a unitary glass lens into a single plane, and they're usually made out of plastic that's very lightweight and flexible. They're used generally to collimate light from a diverging light source, such as in a projection TV or a lighthouse or an automobile headlamp. In our case, though, we're turning it around and we're focusing collimated light coming from the sun to a focal spot behind the Fresnel lens. The schematic view of the water purifier setup, it takes a Fresnel lens and focuses incoming collimated light from the sun onto an extended copper coil behind the lens. Water traverses from an input bucket through the coil to an output bucket. In the course of the day, the sun, of course, moves in a trajectory across the sky, which causes the spot on that coil to move linearly. The coil is designed to have sufficient lateral extent to intercept that spot from about 11 a.m. to 2 p.m. every day.
Okay. So, as I was explaining just before, there are just a few components to this system. This is the Fresnel lens. It's a 62-inch lens. It takes collimated light coming from the sun to the earth, which arrives straight, and it focuses it to a point. The focal spot of this lens is located about here. So it's behind this black coil. So the black coil will intercept the incoming radiation and put it in a spot that's about 3 inches by 4 inches. So the spot is not at the focus, it's inside of that, so the temperatures aren't excessive. But in the morning, the sun is in the east, of course. It hits the Fresnel lens and lands on this side of the coil. In the course of the day, the sun traverses the sky, and so the spot will move from this side to the other side. But it always will stay on the pipe. If the lens is oriented correctly at the right azimuth, the spot will be a linear swath that goes all the way across this top level of the pipe. It heats the water in the pipe, and the heat is conducted through the copper coil to the thermostat, which is in here. And again, this is just a normal car thermostat. It's a very simple device. When the thermostat detects water that's at its opening temperature, the thermostat opens and the water comes out this pipe into this bucket. This is the input bucket. It's contaminated water from the pond in the back. It's got plenty of gnarl in it. It comes out this valve into this coil, goes around and round and round through the spot several times, through the thermostat, and out. So the coil, as you can see, is rigidly attached to the lens, so this whole device moves as a solid object. And that's important because the relationship of the coil to the lens wants to stay the same, but the sun moves seasonally, azimuthally in the sky. So you want to rotate this whole lens on the order of, say, every few weeks. You want to move the lens a little bit so that the spot continues to hit this top pipe.
Okay.
As I mentioned, seasonally, as winter approaches, the sun's elevation in the sky will go down, and so you have a more acute angle, and so you want to raise the lens correspondingly. To do that, you simply adjust the chain to move it a notch, like so. You have to do that on the order of every few weeks, perhaps, but again, the seasonal adjustment is required for this. There was not any obvious way to me that you could make this operate throughout the year without any adjustment at all.
What would be the consequences if you didn't change it?
If you didn't change it, the sun would stop hitting the pipe and the water would not be heated, the thermostat wouldn't open, and nothing would come out.
So, how do you test for efficacy?
We actually use a very simple reagent, which is identical to the one used by some government labs that test the quality of drinking water. It's called Alert, and it's manufactured by IDEX. And so they send you a reagent which you then add to your water samples. You incubate it for 24 hours, and then you read the results based on the color that the reagent turns in the sample. I have a subset of the water samples we've taken. On the left are water samples that did not go through the heated coil, and on the right are samples that did. And the color of the sample is indicative of the presence of coliforms in the water. You can see on the left, where they didn't go through the heat treatment process, there's a lot of color. On the right, they're essentially transparent. That suggests that the input water is in fact contaminated. You wouldn't want to drink this, but the output water is effectively sterile. This is the comparator that's provided by this company, IDEX. If the color of your sample after incubation and the reagent is lighter than this, then the sample has less than 1 coliform per 100 ml. If it's darker, it has more. So again, these samples look quite pure compared to the input, so it would appear that the method is effective.
Here we have a sample that was tested by the certified lab showing the similar results, no coliform count after the coil.
So are there any safety concerns about your device?
Well, there are a number of considerations that one has to be aware of, especially when you're dealing with Fresnel lenses. Mostly the focal spot can reach extraordinary temperatures like 2,000 degrees, so you have to be very careful not to have flammable items at the focus spot. Now this device, we don't work at the focus, we work well in, several inches in from that, so that the temperatures aren't nearly that intense. But in general, if you're working at the focus, you have to be very careful and very cognizant of where that spot falls during the course of the day and during the course of a year. You should wear eye protection if you're working in the focus, and you should, again, be very careful with flammable materials in the region.
So what are the capabilities and the limitations of this?
There are two modes that the device can be operated in. One is a steam mode and the other is a liquid mode, and it only depends on the kind of output control valve you use. For example, you can use a check valve, which requires a certain PSI to open that valve, or you can use a thermostat, which requires a certain temperature to open the valve. If you use a check valve, you require the water to boil, and so the output is less because you have to reach much higher temperatures and pressures. If you use a thermostat, the output is greater, but it's not, the effluent has not been distilled. And so the understanding is that when you use the steam mode, the water is required to boil inside the pipe in order to escape. And so that leaves heavy metals behind, it might leave volatile organic compounds behind, it might leave salt behind. And so the water coming out should be really quite clean. The thermostat model, though, it elevates the temperature of the water to the point where the bacteria are killed, but it doesn't require evaporation. So back using the thermostat, we're now using a thermostat that's a car thermostat. There's several examples I'll show you outside. And it simply opens when the temperature is reached and it closes otherwise. It's a totally passive device. It's very cheap and it's low tech, but it's nice because, as I said, it's totally passive. There's no adjustment to make. There's no adjustment. It just simply opens when the sun is up and closes when the sun goes down.
So are there any improvements that you could make to future models, and could you scale it up in order to increase the output?
I think the device is kind of inherently limited by the size of the lenses that are available. These are we've taken from projection TVs, so they tend to be less than about 62 inches on a side. And it's not obvious how you would scale that up to very large numbers. So again, in my vision, this is not really applicable to large-scale water treatment facilities. That's not what we had in mind. But it is applicable to smaller-scale, more remote areas. We don't know how much water we could get out. Right now, every sample I've tested has come out clean. And so I think my understanding is that we have a little bit of overkill. We're getting the water hotter than we need to. We could back off on that and probably get more output. I would guess we could back off another 10 degrees before we begin to run into a zone where we are not effective in purifying it. And at that level, I would guess we'd get 4 to 5 gallons out per day.
So what do you want to do with it now?
Well, we're making this video in the hopes that various humanitarian organizations might take an interest in this and work with us to find some areas in Africa perhaps that could make use of this. I have no such relationships, and I don't really know what the situation is there, what works and what doesn't, what is appropriate and what is not. So I'm reaching out to, as I said, humanitarian organizations that might have an interest in this. We're willing to provide these apparatuses at cost, if that makes it more appealing, and shipping should not be a big issue because it's not a heavy device. It weighs maybe 20 pounds depending on whether the frame and mount has to be shipped as well. If they did have such an interest, they could contact me at the contact information that we're going to provide.
All right. Well, thank you for your time.
Thank you so much. This is what a surge looks like. This is when the thermostat is opening up a bit because of the hot water against it and is letting a bit more volume through.
Cool.
So although it is clouded over now, the sun was out pretty much all day, and certainly from noon to 3, and so I've collected here about 4 gallons of purified water from the input, which we're going to show you what it looks like. And just to make sure you know that this water is safe to drink, I'll have a little right now. It's warm, so it's a little off-putting, but otherwise it tastes great.